Well, hello, pre-calculus students. Today's notes are on hyperbolas. And the previous note, well, we're talking conic sections in this unit. The previous notes were on parabolas, on circles, on ellipses. Today's notes are just on this one conic section, hyperbolas. And the definition of hyperbolas is a little tricky. It's a set of all points in a plane. The difference of whose distances from 2 points is equal. And if we were to graph these, it looks something like this. So if we start with 2 points, and we say, okay, the difference from, now if it was sum, we'd have an ellipse. The difference between these points need to be equal. Our shape is going to look something like this. We're going to have this kind of U shape, not a parabola going one direction, and another similar shape going the other direction. And like I said, these are not parabolas. They're a different kind of shape. It's called a hyperbola, and hyperbolas always come in pairs, so you always see two of these shapes. Okay? All right, now sometimes they're up and down, sometimes they're left and right, and we'll need to address when we see each of these possibilities. But let's get our standard form of this equation down first of all. So here's your standard form of the equation of a hyperbola. X minus h squared over a squared. This looks very similar to our equation for an ellipse. Here's the only difference. We're going to have a minus between these two fractions. And it's going to be y minus k squared over b squared equals 1. Now, like we saw with an ellipse, h and k are going to be the center. Like we saw with an ellipse, A will tell you the stretch in the horizontal direction. So basically, because A is under the x, it gives you the stretch in the x direction, which I'll write as the horizontal stretch. B, because it's under the y's, will give you the stretch in the y direction, or the vertical stretch. Similar to an ellipse, we also have foci. We have a focus here, a focus here. To find those, we're going to use c squared equals a squared plus b squared. Now with an ellipse, we had a minus right here. With a hyperbola, we've got a plus. C will tell you the distance from center to each focus. So we'll put here center to the focus. And I'll say each focus because we're going to count up and down or left and right. Okay, now this particular equation, x squared minus y squared, is going to give us a hyperbola that looks like this, that opens in the horizontal direction. So basically, if it's x squared minus y squared, if the x is our first, it's going to open in the x direction, left and right. If you had an equation for a hyperbola that looked like this, y minus k squared over a squared minus x minus h squared over b squared equals 1. Notice it's pretty much the same formula. H and k is still your center. A and b still give the stretches in the x and y direction. We can find c to find the distance to each focus. But if it's y squared minus x squared, those are the ones that open up and down in the y direction. So basically, if it's x squared minus y squared, it opens in the x direction. If it's y squared minus x squared, it opens in the y direction. Okay, now a lot of this work makes a lot more sense once we look at some examples. So we're going to look at 2 examples today, and that'll be it for our notes. So our first example we're going to look at, here's an equation in standard form, and we need to find the center, the vertices, the foci. Here's something I didn't talk about, the asymptotes, and sketch a graph of this. Now, here's the deal. Do not wait till the end to make your graph. It is in your best interest to graph as you go. All right, but let's just find what we know. Our center, we can get right away. So since 2 is subtracted from x, 2 is subtracted from y, the center is going to be the point 2, comma 2. And over here, I'm just going to make a graph, okay? So I'm going to make a set of axes. Ooh, that's not too straight, but I hope you'll forgive me. And we'll put our center of our hyperbola right there in our graph. Now, from that point, you will notice that the stretch in the x direction, it's always the square root of this number. This is like a squared. So the stretch in the x direction is 2. So if we count 2 units to the left, I'm going to put a dot there. 2 units to the right, I'm going to put a dot there. There's our stretch in the x direction. In the y direction, the stretch is going to be the square root of 5. Square root of 5 is like 2.2, so I'm going to count 2 and a little more down, 2 and a little more up. Now, to make our graph, here's what we're going to do. I'm going to make a box, a rectangular box, that goes up to each of those points, down to each of those points, left and right to each of those points. And here's how we're going to make our graph. So to make our graph, we're actually going to sketch asymptotes that go through the corners of this rectangular box. And we know what asymptotes are. We've seen them enough. We know asymptotes are lines that our curve approaches but does not touch. Okay, now since this equation was x squared minus y squared, we know this opens in the x direction. Meaning, here's going to be our curve. So it always approaches these lines and doesn't touch them. It comes infinitely close to these lines, curves, and just touches this rectangular box at one point, and then it curves away. So there is one part of our hyperbola. Here comes the other. Again, it approaches these lines, does not touch them, curves up, touches this rectangular box at one point, and then curves away. And there's our graph of our hyperbola. Now, from the graph, we can get our vertices. Our vertices are these 2 points, the points where the curve touches that rectangular box. So from the graph, I'm just going to count those values. One of those points is 0, comma 2. One of those points is 4, comma 2. All right, to find your foci, what we're going to have to do is use these values, and we have this formula, c squared equals a squared plus b squared. Or essentially, c squared equals 4 plus 5. Well, if c squared equals 9, c equals plus or minus 3. What that means is if we count 3 units to the left and 3 units to the right, we have our foci. And I'm just going to get those off of my graph. So those points are -1, 2, and 5, 2. Oops. Okay, last thing I asked you for are the asymptotes. Now, sometimes you're asked to find the equations of these lines. I'm just going to ask you to find the slopes of those lines. So the slopes of the asymptotes. Now, it's actually much easier than you might think. Remember, you made that rectangular box. You counted from here up the square root of 5, and you counted from here over 2. There's your slopes. So one of those slopes is the square root of 5 over 2, and the other one is negative square root of 5 over 2. So there's your slopes of your asymptotes. All right, so let's just make sure we got everything. We got our center right away. We got our vertices once we started sketching our graph. We got our foci from this formula here. And we counted the slopes of our asymptotes from the graph again. All right, so that's everything we need to know to find all those characteristics and graph of a hyperbola. Let's do one last example, and we'll call it a day for our notes. Okay, you will notice same directions. Find the center, vertices, foci, asymptotes, and graph. Oh, but man, now our hyperbola is not in standard form. So we need to get it in standard form. All right, we've seen some like this before where we have to complete the square. So I'm going to write my x's together over here. I'm going to write my y's together over here. I'm going to take that 72 and move it to the other side. So basically, I'm just rearranging my equation a little bit. Now, with the x's, you might say, oh man, what do I do here? There's nothing to complete. And that's actually good news. There's nothing to complete, so we don't have to complete the square. So we just get x squared. With the y's, we have to factor out that minus 9 first. Now careful, here's the number one place where people make mistakes. When you factor out that minus 9, we're left with y squared, and then we're left with minus 4y. We'll close our parentheses. All right, equals 72. And just like we've seen before, we want to figure out a number that'll go in this spot right here that will make these three terms a perfect square trinomial. We use the same trick every time. Take half of negative 4, and that's negative 2, and square that. That gives us plus 4. Now, ladies and gentlemen, we have to balance that out. Don't just write plus 4 here, because we're not really adding 4. We're really adding negative 9 times 4, which is negative 36. Okay, that's the tricky part. Okay, so let's clean things up. That gives us x squared minus 9 times in parentheses y minus 2 squared equals 36. And we've almost got it in standard form. To finish it off, we're going to divide every term by 36. That first term, piece of cake, don't mess with anything. Just leave it as is. There's no number to divide. Minus. That second term, 9/36. If I divide those both by 9, I get y minus 2 squared on top and 4 on bottom equals 1. And now we've got our equation in standard form. Now, I'm going to have to find all these attributes and sketch a graph, which means I'm going to need some room to work. I hope you don't mind if we just push this aside for now, because I'm going to fill that space with all those attributes. All right, let's start with the center. The center, well, it's pretty clear it's something comma 2. What's here? Well, since nothing's subtracted, you're really subtracting 0. So your center is the point 0, comma 2. Okay, I'm going to start with a sketch of a graph. Okay, so let's see here. We know that center is 0 left, right, 2 up. So here's our center. Our center's going to be this point right here. And we know our stretch in the x direction is 6. So I'm going to count 6 units to the right and 6 units to the left. Our stretch in the y direction is 2. So I'm going to count 2 units up and 2 units down. And I can make a rectangular box that goes through those 4 points. Now, just like last time, we're going to draw diagonal asymptotes. And these diagonal asymptotes really define where this hyperbola is going to go. Now, it's x squared minus y squared. So the shape of this graph is going to be opening in the x direction. And these curves always approach these, whoops, that one went through, sorry about that. Always approach these asymptotes and don't touch them. They always touch that rectangular box at that one point. Now let's see if I can do better on this side. Yeah, not bad, kind of messy. Okay, now that our graph is done, let's find our other attributes. The vertices are these 2 points where our hyperbola touches that rectangle. And if I count on there, that is negative 6, comma 2 and positive 6, comma 2. To find my foci, I have to use this equation. And this equation, it looks like the Pythagorean Theorem. Works the same way. So let's put our a squared and b squared in here. So that's 36 plus 4. We get 40 for c squared, which means c is plus or minus the square root of 40. Square root of 40 is, I don't know, it's like 6.3 or so. If you want to call it 6.3 and count 6.3 to the left, 6.3 to the right, you've got your foci. Now, another way to write that is to say, hey, we're going left square root of 40, right square root of 40. So if I'm starting at 0 and I'm going left and right, the square root of 40, comma 2. That answer is perfectly okay. If you wrote negative 6.3 comma 2 and you wrote positive 6.3 comma 2, that answer is perfectly okay as well. All right, last thing. We need the asymptotes. Well, now I'll just ask you to find the slopes of those asymptotes. Okay. Well, when we made our box here, we went up 2, we went right 6. So our slopes are going to be plus or minus up 2, right 6. If you want to write that as plus or minus 1/3, you can do that as well. All right, so ladies and gentlemen, here's what we should be able to do. We should be able to find all the attributes we need of a hyperbola, whether we're given an equation in this form or whether we're given it in standard form. All right, that wraps up our notes for today. Good luck finding attributes and graphs of hyperbolas.